All right. For the last presentation today, we want to talk about battery systems in the Canadian market. We want to talk a little bit about the news and the confusion under UL9540 and UL9540A in the Canadian market, because that's a huge topic right now for many installers. There are many issues installers are running into based on problems with their inspections and certified and maybe partially certified systems. In this presentation, we want to cut it into or divide it into two different segments. We want to talk about the new UL9540 certification and the new battery testing UL9540A. We want to understand what goes into both of those systems and how are those certifications being categorized. And then what are really the technical issues we're facing when it comes to the Canadian Electric Code with these certifications. And then in a second step, we will look into what are these specific implications for installations. What does the new 64900 code segment says, specifically the 918? Then we talk about what options do we have available, even though we have these very hard restrictions and very tough requirements in 918. We have two bulletins in Ontario that clarify a few of those things. And then in the last step, we want to look what's actually on the market right now and what is coming to the market and how do those products comply with the requirements that are shown in that system. What I've done, since we have a lot of code references on the top right, I always reference the code we're currently talking about. And that gives you a little bit of better categorization, understanding where we are right now and which code we're talking about. Very quick highlight, the 9540 is now the safety standard for energy storage systems. It doesn't have to be battery storage systems, it can be any kind of energy storage systems from chemical storage like a battery, but it can also be mechanical storage like a flywheel or any other electrical storages like a supercapacitor or something like that. The code is agnostic to the actual technology. Very new, and I'm very happy to see that, is a bi-national standard. So now there is a standard that applies to the US as well as to the Canadian market. So it's easier for manufacturers to certify products that are applicable to both national codes. In the past, a lot of the certifications we see is a UL certification. And then the Canadian certification is sort of similar, but not the same, has a different name, and there's a lot of confusion what is now actually required. Going forward, it's one testing, one certification that applies to both countries. And that's why it's also called ANSI CAN UL for the Canadian and the US market. And then that code mainly applies for energy storage systems intended for grid connections. And that includes standby and battery backup systems. The code categorizes in four main categories. One main category is indoor systems, when you have, let's say, a mixed-use building, like a storage facility, or a dedicated building, or even a dedicated room, like a container, where you put your system in. We have outdoor systems, not very common for residential, but these are these standalone on a concrete pad, where they have their own HVAC systems and heating systems, fully weatherized. Then we have special applications that doesn't really apply to us, what we are doing and probably what you're doing. These are systems that can be co-located besides HVAC systems on commercial rooftops, not very common here again, or they can be placed in parking garages to assist EV charging. And then the last one, and that's the focus of this presentation, because most of the battery storage systems in a small scale are going into residential dwellings. How does the code apply to residential systems? The most important part is UL9540 is a system certification. A system can be an all-in-one system. An easy one is probably everyone knows the Tesla Powerwall. You have the battery, the inverter, all-in-one enclosure. But it does not have to be an all-in-one system. It can also be a field-assembled system with matched components that are all together certified under the umbrella UL or CAN UL9540. So very, very typical, we have the inverter in a system that is certified to whatever inverter certification specification there is. Very standard is the 1741 SA or nowadays SB going forward, as well as a Canadian version of it, the 1071. The batteries itself are also certified to their respective UL 1973, and they can be, and most of the newest ones are, to the fire propagation testing of 9540A. And then there are other components that also can be covered in the same document. That might be your transfer switch or an extra cabinet you want to put your battery modules in, or whatever other components in that system. So the most important thing is UL 9540 is not a component certification. It's a system certification for the interoperability between an inverter with a specific battery or multiple battery modules. So every system that has a combination of a inverter and another battery is a different certification, will have different documentation to it. The main focus of that system certification that was introduced to the Canadian and the US standard is to identify hazards specifically in your residential dwelling. No one wants to have a fire in their home or their basement. So risk analysis and risk evaluation together with a failure mode analysis where engineers and the service or the technical team with UL or CSA or whichever agency is doing the testing, they think about what could go wrong, what could be different failure modes that lead to a problem in that system that could be a catastrophic problem to the customer, their home, and maybe their well-being. UL 9540 goes beyond just the technical compatibility. So for example, it tests, of course, the inverter and the battery interaction. How does the battery protect itself? How does it communicate with the inverter, for example, to be safe in operation? But it also includes that it's documented how you install these systems and what things you have to pay attention to. It also specifies certain separation distances, what capacity can be installed in one increment, and how can you co-locate multiple of those storage systems to achieve more power or more capacity together. Most of the time it's an energy limit just from a fire safety, that you have not all critical components lumped into a big pile of equipment, but you can separate them and therefore have lower risk by physical separation. Non-residential systems, so systems that you would put in a commercial system or a parking garage or other units like a container, might need additional protection. So for example, a containerized system, depending on the chemistry they are using and depending on the capacity they're using, they might implement also fire suppression, fire protection, explosive venting, that if something happens, the system will still be safe or reacts to the certain incident in a way that doesn't go into a catastrophic situation. And then all that together also has the documentation about the fire propagation testing. That is the next code we will talk about it, but also its results and the testing organization. So UL 9540 not only certifies or tests the system, it also requires manufacturers to deliver you the documentation, what they have done, that you can take that documentation and hand it over to a inspector, for example, or for any reviews of your plans for installation with that inspection agency, like the ESA in Ontario. We now add an A to the UL 9540, and now we come from the system certification to the underlying, that is part of UL 9540, the fire testing standard. And the fire testing standard is mainly a standard or a testing procedure to check what will happen in a thermal runaway, or if there even is a thermal runaway in the first place, and what is the aftermath of that thermal runaway in regards to safety and further fire-related or safety hazard-related things. So the scope is, that's the definition, the test methodology that determines the capability of a battery technology to undergo thermal runaway, and then evaluates the fire and explosion hazard characteristics of a battery energy system that have demonstrated a capability to undergo thermal runaway. And the important part is that currently all lithium-ion cells have a problem for thermal runaway on the cell level. And we will talk about the 4 steps, an energy storage system, and the fire testing is done on each level of the components. The lowest level, of course, is always the battery cells itself. So they take a cell, they test the thermal runaway by heating up the cell, and they measure exactly with a diagram, and we will see one a little bit later in the next slide, when that cell is going into thermal runaway, and that will be taken as a measurement for further testing when it comes to module, unit, or even installation level. So the cell is the lowest level, then multiple cells are typically packaged in a battery module, and then multiple battery modules typically form a unit, so an energy storage unit. And if you install multiple units in an environment like a containerized solution for commercial, then you can also certify or test that system. Certification is the wrong word, it's a testing to an installation level that includes all the other safety mechanisms like a fire suppression system or a smoke detection or a sprinkler system, for example. Let's start quickly, or exactly, the outcome will be a test report that shows exactly how is that cell, module, or unit reacting to that test, and if there is any fire, flame, some flammable gases that or accumulating of gases, all that will be tested. But the UL9540A is not a certification on its own. It's just a testing method to support the UL9540 system testing or certification. Jumping right into the cell level here, the cell level test determines if there is a thermal runaway. The answer I already gave, there will be a thermal runaway with pretty much any commercially available cell in this market. Doesn't matter which manufacturer, doesn't matter where it's coming from. Lithium ion has at one point a thermal runaway event. It also determines when the cell is venting. Venting meaning just releasing extra pressure over a pressure valve that opens up to not explode. It determines the temperature where that thermal runaway is happening, and the test environment collects data about what gases are being released, how critical are they, and do they have a flammability level that might lead to a further ignition of those released gases. So what we see here is a typical curve, temperature on the y-axis and time on the x-axis, and here the cell is being heated with about 4 to 7 degrees per minute. And it gets hotter and hotter and hotter and hotter. And at one point, there's a little rise in temperature. And here the cell starts venting at one point, so the valve is opening. Once the valve is opening, the temperature stays a little bit more constant because you're releasing energy by venting into the environment. And at one point, the venting is done, and the temperature is still rising, 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 until a point where the temperature is pretty much is rising uncontrollable, and that's your thermal runaway event. And that's pretty much the critical moment where the system is not in a stable situation anymore. The performance level criteria is, so if you would have a test unit, so a cell, and you would, or the testing facility would see no thermal runaway, and there are no flammable gases, then the cell would pretty much pass that test on the cell level. And then that system would be nothing else like a toaster in your household, because you can place that toaster anywhere you want, even in your bedroom, and it's like any other device you plug in. So this would be super safe, can be used anywhere. Unfortunately, as I mentioned, that cell doesn't exist, so we have to go to the module level. The module level now has multiple of those cells to form a module at the right voltage and the certain capacity that you can use in your system. And the testing lab has also multiple test steps. They will check what happens when the thermal runaway is happening within the module. They will check, are there any flames coming out of the module? What is the actual chemical heat release rate? So how much energy is being dissipated out of that module into the environment? Is there smoke coming out of that module? And if, how much? And what's the rate of smoke? And then are there any explosion hazards when those cells are being put into a module? Here we have a picture from a battery manufacturer we are carrying from their UL9540A test. And I put a little screenshot from the test report. And you see here, observations during test, first smoke released from module at a certain time, no flying debris or explosive discharge, so that's very good. No sparks, no arcs or other electrical events during test, perfect. No external flaming observed. So the cell itself did not pass UL9540, but the whole system was put into a cabinet, and the cell within the cabinet was actually able to pass that testing. So you see the brand, multiple other brands of battery modules and cells also are compliant with that module level test and pass the test at this point. But what if you have a chemistry that is maybe not a lithium iron phosphate like this manufacturer here, and you have a NMC that has a significant higher heat release rate and thermal runaway from an energy perspective? You have to do probably a little bit more, and maybe your module will actually have some exposure or flames are coming out. Then you need to go into the next level. Quickly, the performance level criteria. If the thermal runaway is contained by the module, which in this test we've seen it is, and no flammable gas is coming out, then that criteria is confirmed and you can stop the test at this point. If that's not the case, because if you have a different chemistry or your layout of the module is not to par or are some issues with the design, or wait a second, that's my analogy. If that is tested, then you have like a wood stove in your house. So yes, there is fire in the wood stove. You have controlled the fire in the stove, and the stove itself is still safe because everything is designed to handle that fire or smoke within your house. Jumping right to the unit level of a system, and the unit level we can divide into multiple different options. Let's start with the residential criteria. So you can have floor or wall-mounted system, typically they are indoors, and the system, so all the cells in the module in the unit, they can also not have any flaming outside of the unit that come out of the battery storage system. The surface temperature needs to be below the venting temperature, so they cannot ignite or heat up adjacent systems and adjacent modules. The combustible construction, so if the system gets hotter and hotter and hotter, cannot ignite surrounding material. So for example, if you have a cabinet and you put that in front of a wooden wall or a studded wall or whatever you have in your basement or any room in your building, the temperature cannot exceed 97 degrees beyond the ambient temperature, just to make sure that there's not excessive heat being put into the environment and the walls, for example. And you cannot have any concentration and accumulation of flammable gases within that cabinet that exceed a certain level, in this case 25% of the low flammable level in a volume of the room, so that the room will never have any explosion as a result where these gases could ignite and cause a problem. Non-residential is pretty much the same as we already have seen on the residential, but in addition, there is a path here or another level that the heat flux, so the radiated heat into an egress path. So if there's a walkway, for example, to an emergency exit, if a person would walk through that walkway, the radiation and the heat to that person cannot exceed that certain radiation level, in this case 1.3 kilowatts per square meter, that the person would not get burned by that very hot system he or she is working past. For outdoor and ground mount system, things are a little bit less strict. You have the same as the indoors, but if you do have flames, then you have to have a certain separation requirement that the battery system has a certain distance to any other components with the flame length. So if flames are shooting out of the system, you can have no other equipment or building or structure within distance where the flames are shooting out. That's pretty much the worst case example, because it's really a system that is already burning and quite badly damaged. And in order to protect life and buildings, you have to have a certain separation. And then the last test, and I put here right there, commercial only. Typically, if you have NMC cells from other manufacturers and not a lithium iron phosphate, which is a little bit more benign to these systems, you have to add, or the manufacturer of that battery storage system has to add multiple levels of additional safety. They can choose whatever they need to pass that test. And for example, that could be a sprinkler system in that container with a certain water flow and a certain amount of sprinkler density to cool down that system to maintain that level. They can also use some fire suppression where they have a CO2 or other fire suppression gas that is being inserted into that container. Thermal exposure to walls, things like that. Smoke detection needs to be connected to an alarm system. And they can pick and choose whatever they need to pass that inspection. Again, that's very high level for commercial. We don't want to go too deep into it. But what I'm writing here is it's very, very tough to comply with the 9540A fire testing or large fire testing if you use an NMC cell, like typically used in automotive, or an NCA cell that has just a much, much higher likelihood of a thermal runaway, and then the amount of heat being produced and dissipated is significantly higher than LFP. Key takeaway to summarize that, UL9540, including the Canadian part, is a system certification. So inverter, battery, cabinet, transfer switch, whatever you want to cover, or the manufacturer wants to cover under that, is in one document. The 9540A is not a certification, it's a test that provides the values to the certification under 9540. Not a single lithium cell currently on the market has fulfilled the cell level requirement, and that's important later on when we get to the second half of this presentation, that actually passes the requirements of UL9540A. And then most batteries fulfill the criteria if you put that cell into a module, or then the module in a unit and have it in that contained environment. And the easiest cell chemistry to actually do that without adding more and more safety level and then of course cost to the system is a lithium iron phosphate, so an LFP battery, and they have the lowest energy release rate in a thermal runaway condition. So now we switch over to the Canadian Electric Code and the implications. Yeah, go ahead, Bilal.
Go back to the last slide. What is the path forward? Is there going to be improvements to lithium cells, or is there going to be more prevalence of lithium iron phosphate available in the market?
It's a very hard question to answer because that would be the glass ball to look into the future. My gut feeling is that for the foreseeable future, we will see LFP as the predominant chemistry because that's proven, available, cost-effective, and reliable in that environment, even though it would not fully qualify for the cell level. If we look maybe 5 or 10 years in the future, we will see what kind of technologies and chemistries there will be on the market that may be available that to not have that thermal runaway event. And if something like that comes out, that would be, of course, the easiest path into getting your system certified because we're back to that toaster analogy that you can just put it in any room you want because there's no hazard coming from that system and that electrical storage system. So with the adoption and the introduction of the Canadian Electric Code in 2021, a new segment was introduced, and that is 64900, which wasn't there before. And 61900 is talking about energy storage systems. And it introduced to the Canadian market that ANSI CAN UL9540 and its subsequent fire testing, which we just looked at. And that was when things got really complicated. Because before that, it was flying a little bit under the radar. It's an assembly of multiple batteries with whatever certified inverter you have, and you could pass inspection. These days, with that requirement and the code as it's written right now, it's very, very difficult. So what is the code actually saying? And I picked the most critical section of that code. And just a high-level summary where the problems really lay. There are other problems, but these are the main ones. So we are here in 64918. And the first thing is the marking needs to be suitable for use in residential dwelling units where permitted. So no system on the market today has that label on the, or that sentence on the type label. That's the first problem. Second, the system cannot be below grade and cannot be on floors higher than 23 meters. And the reason for that is it comes from a firefighter point of view. They typically, with their ladder trucks, should, or maybe can if you're in Toronto, but if it's the regular city, 23 meters is probably the highest height. They want to address these systems, and they don't want to go into a basement to address a fire in a basement for energy storage systems. It gets worse. Energy storage systems above 1 kilowatt hour shall not be installed in a dwelling. So that's the death sentence if we just read that to begin with, because you can pretty much not do anything. You can get a little UPS system that is based on lithium to power your router, but anything meaningful cannot be installed. ESS, so energy storage systems, shall be permitted in garages of dwelling units. There's typically a limit, 20 kilowatt hour per increment, or a total of up to 40 kilowatt hours. That's not too bad. And then if you have a detached garage, a storage, or even a freestanding structure, so something that is completely detached from your building, then you can even go in 20 kilowatt increments up to 80 kilowatt hours of that system. And then lastly, and that's one of the big topics which we just have discussed, ideally to be compliant, the marking needs to be this equipment meets the cell level performance criteria of UL9540A, shall be permitted to exceed, that's the first part that no system can achieve. So this is already off. And if you would have that, then you could actually go above the 20 and 40 kilowatt hours and above the 20 and 80 kilowatt hours in those structures. So multiple problems in multiple levels. And the question now is, how can we do anything if we're restricted with the wording that we have right now? And unfortunately, the wording is pretty poor and not very refined. And the Ontario Electrical Safety Authority, based on that wording and lots of confusion in the industry, brought out a bulletin, or actually two bulletins. They brought out the 64.7 bulletin, so for section 64, and another bulletin for section 64, number 8. Now we want to jump into the more relevant one, that is bulletin 64.8 here. And we look into what options do you actually have available if you want to install something in Ontario. And I have to put one sentence in here as well. That is what the bulletin and what the code currently provides, black and white. That does not necessarily mean that your inspector you have has read that bulletin, understands the bulletin, and follows the thought of that bulletin to approve your system. That is the big issue right now, that even though we have something that clarifies things, it will still, and is still an issue for some battery storage systems being deployed to this day. So, first option, and that's probably the easiest, the residential battery storage system is certified to 9540 and the 9540A testing, and is marked with the two sentences we already have, suitable for residential, for use in residential dwelling units where permitted. This equipment meets the cell level performance criteria of UL9540A. We already know this is not going to happen. It's not the case right now. Second option, or here, if you have that, you can install that in the living or habitable areas of a dwelling. That would be your living room or even your bedroom.
How about your basement?
That can be also installed in the basement. There are no restrictions because you have that cell level performance criteria, and it would be that toaster analogy that you can plug in wherever you want because there's no hazard coming from that system. Again, unfortunately, this category is off the table. It does not exist. Second option. You can have the same system certified, but it's not marked with these things because most likely your battery manufacturer or your system provider has not passed the performance criteria of the cell level, and they may or may not have that additional sentence on the type label. So in this case, Bulletin 64.8 allows you to install that system in a non-living, so not your living room and not your bedroom area of a dwelling. For example, you can install it in a utility room if the customer has one. It can be a storage room. It can be an attached or even a detached garage. Attached garages are not really a problem because even if your garage is within the building, so within the envelope of the building, by the Ontario Building Code and any other building code in Canada, the fire rating of your garage to the rest of your building already has a 1 hour fire rating and is therefore by code a detached structure, even though it's in your house. So you can install it in a garage that is within your building. It doesn't have to be distanced away from the actual dwelling structure. So this is where things get a little bit more refined from the messaging and a little bit easier that there are now options where you can install things. All right, there is another option available, and that goes to a few of the other points I mentioned earlier. You can install inside dwellings, and that refers to the 1 kilowatt problem and the below grade problem of the thing. If the room you install the energy storage in does not open directly into a sleeping area or bedroom, so there's no door that directly exits or goes into a bedroom, then this room would be a suitable room to put that energy storage system even in your residential dwelling. Second, the room you're putting it in has to be a minimum fire rating of 1 hour, so you have to have your whatever special drywall doubled up or whatever other structure. The room has to have an interconnected fire alarm. So you have these fire alarm systems where you can link them either by cable or by a radio signal, that if smoke is detected, the other fire alarm in your building is also being activated, that you know that your room, basement, storage unit, whatever, has a fire incident. The individual energy storage system cannot exceed 20 kilowatt hours, and multiple systems cannot exceed 40 kilowatt hours, and we have seen that before. These are the limitations anyways for a residential install in a residential dwelling. And you have to have a minimum distance of 1 meter between each increment of up to 20 kilowatt hours. Or if the manufacturer specifies and has testing, that they went to a lab and have tested their system in closer distance. For example, a Tesla Powerwall can be stacked. And lately, there's a special bulletin from their Tesla engineering and their lab that you can now actually stack the battery modules again back to back, which was not possible just a few months ago because of that testing requirement. Now we can do that, and if any other manufacturer has a test like that as well, that they have one rack with 20 kilowatt hours, and they have tested and documented it with another rack of 20 kilowatt hours, pretty much side by side, then the manufacturer specification and installation instructions will supersede the 1 meter requirement in the code. And the storage system has to be distanced at least 1 meter from any egress path or window that is in that room or building you put it in. So, and the most important thing is, and that goes to your question, this includes even the below grade installation with that deviation request referencing Bulletin 64.8 and that 64.918 in the code. And that's typically what's being done right now for most of the installations for battery storage. There's another option. If you don't want to install it in your basement or in that residential dwelling directly, you can use the attached garage or detached garage, same thing. If you meet the following criteria, very similar to what you already heard. A single system cannot exceed 20 kilowatt hours. Multiple systems, in this case, because it's separated, can go all the way up to 80 kilowatt hours. Same distance requirements, either 1 meter if it's not specified, or you can align them if it's actually tested and specified by the manufacturer. And if you have a garage available to you, this is by far the easiest option for you to go with, because that does not require a deviation request, has the least amount of hoops to jump for interconnected fire alarm or smoke alarm and all these requirements we had for the deviation request. If you have an entirely detached structure, like a dedicated dwelling, let's say you have a farm, and the farm has a house, and you have probably a garage or a shed or an electrical room extra where you have your pole and your transformer on it, or whatever structure that is on the same property together with a dwelling. Then you can still do the same thing as we had, 20 kilowatt hours for a single system. You can do 40 kilowatt hours for that system total. You still have to have the spacing, and you still have to have the distance, because it's now in a building, from 1 meter, or at least 1 meter from doors or windows for egress path. And yeah, and the structure, so the building needs to be at least 1 meter apart from your actual dwelling if you want to be in that category. And the easiest installation, again, is if you have such a house, garage, whatever barn available to you that is separated from the residential dwelling.
Are you allowed to have a car in the garage with the lithium?
You can have a,
battery?
yes,
With the lithium
yes,
battery?
yes. There's another, which I didn't list here because it's not as critical. If you have a potential that a car could hit your battery, for example, you install it in your garage all the way to the front, and you park the car right in front of it, then you need to have bollards that in case someone is driving the car, that they cannot directly hit your battery to protect the battery system from accidental driving. Yeah.
Just go back and look at criteria E and criteria B, Bravo and Echo. How can we not exceed 40 kilowatt hours, but also?
You can exceed 40 kilowatt hours, but if you do that, the building needs to be a minimum of 1 meter away. So it's not either or, so it can be closer than up to 40, because then you are in the residential category. If you want to be above 40, up to 80, then you need to have a minimum distance from that 1 meter.
Got it, thank you.
So, approval requirements. So what is ESA in that bulletin number 7 now? That was the first bulletin that came out. Requiring energy storage systems to carry, and what options do you have for certification? So the easiest one is you have a fully certified system. So what happens if you don't have a fully certified system? You have the option 2 available to you. So you can do a product or field evaluation under the SPE 1000 to the requirements of 9540. So that sounds easy, but it's not as easy as it might be listed here on that bulletin. Problem is that it's relatively expensive, and a lot of time goes in. You have to do a lot of communication with your testing lab that comes out and does the SPE 1000. And they charge you quite a bit of money for getting your system certified with the components you select. And then we have another system that specifically applies to lead-acid batteries, and that's an exemption that helps for legacy systems or very small systems or even backup systems that are still based on, for example, HEM batteries. You can get an acceptance by your ESA inspector if your system meets the following conditions. So you have to have lead-acid batteries. They can be, for example, the most common one is HEM, as I said, or a gel, so a sealed battery for battery backup systems. All the components you're using, so the inverter, the transfer switch, your DC combiner, if you have one, a charge controller, if there's one involved, any other component that is being used need to be approved to their respective certifications or approval. And all the parts need to be installed according to the specific manufacturer's specifications. So the inverter has a manual that states it has to be installed a certain way. Your electrical panel you use needs to be installed in a certain way. And on top of that, you have to, of course, use the Ontario Electrical Safety Code wiring standards, which is pretty much the standard electrical installation any electrician is following anyways. And if you fulfill all of those options, then you can still use lead-acid batteries in residential dwellings. This is also not super easy because you are reliant on the inspector to understand what you have done here. So you have to communicate, you have to prove this is certification A for the inverter, this is certification B, this is how I've done it, that's the batteries I'm using. And technically, there shouldn't be any problems, but most inspectors, are not very comfortable doing that kind of site inspection because they typically just want to use an easy way checking it or have someone else prove to them that things are already pre-inspected or field inspectors or certified elsewhere because it relieves them from their, let's keep it at that. So, key takeaway number 2. If you have the chance to buy a fully certified unit or system, pick that first because that's the easiest path forward with certification. Make sure you also get a documentation that has all the components on it. There are some manufacturers that only test their battery and only test the cabinet to a former standard. For example, the UL9540, there was a standard in 2016 that you can certify system to on their own. But the newest version and the current version you have to have it certified to is the 2020 version of 9540, if I'm not mistaken. And that includes that all components have to be listed and all components have to be tested with each other. So you cannot just use I don't want to use the name of the brand, but they have a cabinet and their own batteries and they say their cabinet battery is UL9540 certified. That doesn't exist because the inverter is not specified. That goes with that cabinet plus battery system. Second, make sure that you have the underlying UL9540A testing documentation available to you. That is part of that certification, but a lot of inspectors want to have the total paper trail that they can file with the case, and then they can just say, oh, this is a certification, that's why I have approved that system. If you can, prefer installation locations that are garages, detached or attached, if possible, because that, as we discussed, allows you to not get a deviation. You not file for deviation. You don't have to prove anything because that is already much easier path going forward if you put it in a garage or a separate building. And then these systems also need a disconnect switch similar to your solar system. That needs to be accessible from the outside. That is within the 64.7 bulletin and these code references I have here. A lot of people install a system and technically do not install a service disconnect that is outside for whatever the utility company or firefighters or whatever. We don't want to discuss the use and of that switch, but it has to be there by code, and it's the same standard outdoor rated NEMA 3R switch you're probably already using for a solar inverter. Jumping into what's available, I made a list, did some research. There are also products on the list here which we're not selling, but just to complete what's currently available and installed in Canada. It's maybe not a complete list, but it's the predominant options that are available. You see here in that column the full home backup, because most customers today prefer if the entire home is on backup. We have the UL9540 system certification. We have the fire propagation testing under 9540A. And then we have the marking and the listing on the type label if it says suitable for use in residential dwelling units where permitted, and or if this equipment meets the cell level performance criteria of UL9540A. And the most important thing you immediately see, none of those systems have a marking on the type label that says suitable in residential dwelling right now. So that's going to change most likely with some iterations of the manufacturer changing their labeling. And none of those manufacturers have passed the criteria for the cell level fire propagation testing. Multiple combinations here. You see, for example, the newer Solar Edge system is full home backup, has the UL9540 and passed the UL9540A. The combination of Solarc HomeGrid, Solarc Simplify, and Solarc Fortress is listed with that. The Canadian Solar EP Cube is fully UL9540A and has a full home backup. The Duracell Iguana, formerly the Power Center, has both UL9540 and UL9540A, even though that system does not provide the homeowner with a full home backup. The combination of Schneider and lead acid, because lead acid currently cannot be certified to UL9540. The UL group that defines the standards are currently working on a testing method for UL9540A for lead acid, but that's not the case right now. So all the typical off-grid systems are not falling under that system certification. The SMA system with BYD currently has UL9540 in the 2016 version, but the BYD battery doesn't carry the UL9540A fire propagation testing. And then what else do we have? Growatt, for example, Chinese manufacturer here, they have a combination where they have full home backup, full certification under 9540, and they also pass the UL9540A specification. And then Ginglong, also Chinese manufacturer, has both the UL9540 with the pylon tech and the UL9540A system, but this would not be a full home backup either. So as you can see, there are multiple options, but each system has different characteristics that are already certified, compliant, or maybe do not have all the features when it comes to full home backup. But the big thing is here, as we see it right now in the industry, none of those systems really hit the nail on the head when it comes to the wording as we have it in the CEC 2021, as well as in the bulletins for Ontario. That would be the end of my presentation. Maybe you have some questions. I hope you have some questions. This is a very hard and very dry code topic, but there's a lot of confusion in the market, and I hope that gave you a little bit of an overview where things are coming from and what options you have available today to deploy battery storage. The good news is battery storage deployments right now is the same as probably solar installations in 2010, 2009 in Ontario, where ESA didn't have a clue either what's happening and how systems are installed and what they really want to focus on. And it just takes time until everyone is on board, understands what certification implementation is and what products are on the market and how things can be installed in typically residential dwellings. Bilal?
So you are confident to say now that the ESA understands all it?
I'm more confident than 10 years ago what I have experienced myself. It really boils down onto which inspector are you getting, how willing is he to educate himself and be interested in new technology. And it was the same with solar, that people just had to learn and get exposure, do more and more systems. And the more systems they do, the more confident they get and the smoother your inspection is going. And the same thing will happen with battery storage.
My real question is do you think there's any opportunity where we could, as an industry, get inspectors in a room with the Alexes of the world to have these conversations directly with them and help them to understand from a manufacturer perspective, from our industry perspective, what the expectations are, how we should be understanding these things together?
That would be definitely the ideal scenario, that inverter and system manufacturers and battery manufacturers work together to educate UL with how they test stuff that also carries over into the Canadian market, and then to your point, carrying over into each province's authorities, ESA here in Ontario, whatever, TechSafe BC, and pretty much every province from coast to coast to coast, that they know what's in the code, how can you deviate, and what are other provinces and agencies doing to allow these kind of things going forward. So there is a remake of that wording already underway. It just takes time until everyone has their comments and senior inspectors are heard, and the industry is also pushing back on some stuff. Okay, we need clarification. What can be done, similar to what we already have received with that ESA bulletin number 7 and 8. Danny?
I think this is really a job for CanRIA. I think I would encourage anyone that is a CanRIA member to reach out to CanRIA and mention this. And I think we should do the same. As a CanRIA member, we should reach out to them as well and bring this up with them, because they're doing a lot for solar and definitely a lot for wind, but I don't think they're doing a whole lot for storage, and that's part of their mandate as well. So maybe something we need to reach out to them for.
Yeah, fully agree. That would be their next wind or solar, just in addition to solar storage, for example, or solar in your residential dwelling. Yeah. Go ahead.
I have two comments. One is the SPE SPE 1000. When SPE 1000 is conducted, it does not relieve the vendor of any liabilities that might come in the future.
I'm not the expert for the certification tool. It's a statement, yeah.
So that's a risk in itself.
Exactly.
That's a risk in itself, that if somebody's going that route, one should not forget that there is liability on the vendor that provided that equipment and had it field inspected.
Exactly.
The second thing is, in terms of the separation distances, as per manufacturer's recommendation, yes, it is acceptable based on the UL9540A test, but ultimately one has to live with this equipment for the next 20 years. And this is where the insurance companies come in. And they have their own guidelines.
They might have their own guidelines. So
not might they have their own guidelines.
typically it's based on the NFPA in the US.
It is even more stringent than what the recommendations from the manufacturers is. So if one is looking at an energy storage project, and the first thing is to refer to your insurance company first as to what their recommendations are in terms of separation distance.
Can be. Yeah.
That has a huge implication on the whole financial modeling with energy storage.
That's true, but going back to the 10 years of solar, we had the same discussion 10, 12 years ago. If someone has 5 kilowatts on their roof, how does it affect their building insurance and their home insurance? And the exact same topic will happen in the battery storage certification, and that's exactly where the UL9540 actually comes from the NFPA in the US and the NEC code, to provide a safety level that does not pose a significant risk to building and life, and therefore some documentation for insurance companies to provide that insurance. But you're fully right. At the beginning, this is a huge issue because they don't know either. It's also new for them.
Even among the insurance companies, it's totally different requirements. I mean,
of course.
Project, the requirement was 8 feet on an outdoor installation pool. And I went to 3 different insurance companies and I got distances between 12 and 20 feet.
Exactly, but that could be also for systems specifically for NCA and NMC batteries. So for example, systems that are installed in Ontario here or Toronto Hydro, the requirements are significantly more stringent based on, for example, Samsung SDI cells that are being used that have a very, very different risk profile under that testing. And therefore, you have higher safety requirements.
Actually, because of some of the regulations that you highlighted, there was supposed to be a project at the Parliament building in Ottawa in which they were going to install the battery storage underground.
Mm-hmm.
Took 3 years and they finally said, no, we're going to hold it because of the code
Yep.
and review it again.
Exactly. We are in the early stages of that technology, especially when it comes to regulation and policy. And we have a long way to go until everyone is on board, manufacturer, ESA, building codes, or yeah.
I remember selling microfit systems back in, 2013, and the homeowner said their insurance company was going to add thousands of dollars to the home insurance that he had. So he ended up changing insurance companies because of this, but he still went ahead with the solar project, but he did have to change insurance companies, right? And I think eventually insurance companies don't like losing business, and they will copy each other. So yes, there's obviously some headaches with this, but it comes down to communication with the customers at the end of the day, and that it's just the nature of it, right?
What kind of really put this into perspective was that there was a large energy storage system in Sydney, Australia, and that caught fire.
NMC.
Yes, and it took 27 days before they could actually reach that.
One of the reasons why that testing and certification exists.
And the only thing was that it didn't have any fire detection or suppression system. I mean, these days there's alarm systems for monitoring venting of gases from battery energy storage systems. And you can even isolate and shut down certain sections of the battery energy storage system. So things will develop as they go through, but I think it's some of that case there, and there was another one in South Korea that happened. Another one was in California, actually, one of the largest energy storage systems. And actually that was averted. That was averted even before it went into a thermal runaway. So they will all have implications.
Of course, every manufacturer has to learn, and it will not be the last fire, 100%.
Just one more.
Yeah, sure.
I know this is probably going to be posted on YouTube or whatever. Can you make this portion of the presentation available via PDF?
Sure. Can send that to you.
If you want a direct copy of these slides, just email marketing@Frankensolar. I can't post these publicly, but if you request it from marketing@Frankensolar, I can send it over to you.
Natalie?
Yeah, sorry. I just have a quick question for you regarding just globally or at least North America. Do you find like is this UL9540 or
9540.
Oh, 40, sorry. Is it strict across the board in North America? Is it just Canada that's experiencing these barriers, or?
It's a North American certification and a North American testing standard. So Europe, for example, does not have the same testing standard. They have some IEC testing standards that also cross-reference to 9540A for some of those parts, but it's not nearly as stringent and as penalizing to residential storage systems as it is in North America. So for example, Germany or Europe, the European market, has an extremely high adoption rate on new solar installations in residential dwellings. More than every second system that is being installed has already a battery storage installed right away. So the number of storage systems is significantly higher than in North America.
So just to go on that point, so is it just a matter of like you said, kind of moving our market a little further?
Everyone has to learn, from the manufacturers to the testing agencies, to insurance companies that were mentioned, to building inspectors. It's a new thing, even though it's not really, but it's still new for everyone. Yeah.
Also probably a little bit harder in Canada than, for example, California to put battery storage outside, right? In California, you could probably put it outside because it doesn't get -20.
And that's what's being
right?
done actually for a lot of those states in the US, that you have outdoor rated enclosures that literally are on the facade of the building with the same code requirements, by the way. Yeah. Very good.
What do you see? I mean, in the past we've done a lot of lead acid, right? Still see some of that, but you know, it's maybe not the topic specifically here. But how do you see the future on energy storage, lead acid versus lithium ion?
Very good question. I would probably separate that in two main categories. I would separate that in the off-grid market, unheated cottages and rural systems, and then the on-grid, more residential, suburban installation. When it comes to residential systems, the market trend is as clear as it can get. It's pretty much 100% lithium ion. There's almost no manufacturer that is still proposing new battery storage systems that use a lead acid in AGM or gel or any smart carbon, whatever's on the market these days. It's pretty much all lithium ion. When it comes to the Canadian market and off-grid, we're still facing extremely low ambient temperature, specifically for cottage systems that are maybe not heated year-round. There, a lithium ion chemistry is still very challenging when it comes to the storage part of it, as well as the charging part in very low temperature environments. There's no good solution on the market. There are some chemistry that are a little bit better than typical standard lithium iron phosphate. LTO cells, for example, can have very low storage temperatures and charge and discharge. It's not really commercially available in scale and cost effective, but for most of those systems, lead acid will still be or play a role in that specific application. Bilal?
Bit of a crazy question, but I guess on the same topic, do you see a third option being available in I know there's a lot of experiments now with energy storage and different technologies. Are there any new technologies that you see that could potentially play a role in residential storage in the future?
There are some companies, for example, Redox Flow. There's a company in Australia that does a system with Redox Flow. They haven't made it in the past few years due to a multitude of reasons. It's going to be challenging, and there's a reason why all the big players pretty much focus on lithium ion chemistries, and then more specifically, typically lithium iron phosphate. Because if you look at the entire feature set and risk and packaging and deployment, life expectancy, maintenance, and so on, and cost, of course, lithium iron phosphate currently is definitely the market leader for stationary residential storage.
We are also developing sodium cells.
Exactly, that's just a variation of lithium, so sodium. It's more for a very high cycle life, has a big advantage, but still has similar issues when it comes to
For the temperature has a wider range.
operation temperature. Exactly, yeah.
How about the crystal and nanocrystal batteries?
Typically lead nanocrystal, or which ones?
Yeah, lead nanocrystal.
That's pretty much a version of lead acid. Same.
Comparatively safer than lead acid batteries.
Safety necessarily is not the biggest issue with a lead acid chemistry, because what happens, the most critical part is overcharging, and that's exactly the testing standard that's currently being developed by UL to test lead acid batteries or any variation of it under that UL9540A. And the overcharge is the most critical point. So most batteries, if you overcharge them, you go into a gassing phase and the valve will just relieve excess pressure. And you gas and gas and gas until there is no electrolyte anymore in that cell. So it's probably similarly safe from a testing perspective than an AGM or gel battery today. But from a commercial point of view, I think it will not win the game in residential storage systems based on size, weight, cost, and then longevity of the cells. Yes, they're better than a regular lead acid, but they're still not even close to modern lithium iron phosphate or then even lithium sodium chemistries from a life cycle and service life cost. Yeah.
What do you expect on the pricing of storage? What do you forecasting over the next few years?
Very tough question. I can only speak to what we are seeing as a distributor from multiple battery manufacturers, what happened over, let's say, the last 4 or 5 years. So we definitely can see a cost reduction push for lithium ion, specifically with new companies coming into the market, like some of the Chinese brands we discussed earlier. For lead acid, we have the opposite effect, that lead over the last 24 months or maybe 3 years got significantly more expensive, to the point where a lead acid chemistry and a battery bank on lead acid is not that cheap anymore compared to a similar capacity from a usable perspective, lithium iron chemistry. So the decision to a lithium iron chemistry with the new players and the reduction in cost is much, much easier than it was probably 4 or 5 years ago. That's why the market and market volume in battery modules for 48 or even higher voltage systems is exploding compared to the previous sales volume in lead acid. Yeah. Thank you very much. Appreciate it.